Hi, calculus students. So here's a short video introducing slope fields. So slope fields are we have the definition right here. This is a very formal definition that I kind of want to help explain you through. But it says a slope field is a graphical representation of a differential equation on a finite set of points in the plane. And I know that's like a lot of vocabulary, which is why we're going to break this down. So first of all, I want to remind you what a differential equation is. A differential equation is just an equation involving a derivative of a function. So an example of a differential equation could be dy dx equals x. I don't know, x plus 1. Let's say that. Okay. And a differential equation could have infinite solutions. We can solve it just by solving for y. So when we find y, that's kind of like the antiderivative of dy dx. So we're taking the antiderivative and we would get 1/2 x squared plus x and then plus c. So we have this option of getting infinite number of solutions when we have this plus c. And remember, this is what's called our, the infinite solutions is when we have our general equation. Or we could have a particular solution, or finding the particular equation, particular solution or particular equation. And this would be at a single point. So this is if I'm given what's called an initial condition. So if I were given an initial condition, I could solve for that value of c. So maybe I'm given the initial condition 0, 5. I think I need to switch colors so this doesn't look so hard to see. So if I'm given the point 0, 5, I would plug 0 in for x and 5 in for y. And I'd get 5 times 1/2 0 squared plus 0 plus c. So obviously c equals 5. And then my exact solution, or my particular solution, is y equals 1/2 x squared plus x plus 5. And so here, I'll stick to my color coding, we have these solutions to the differential equations. So I just wanted to remind you of what a differential equation is. We already know how to solve differential equations algebraically. That's what we just did. But a slope field is going to be a graphical representation of that. And so we're going to be focusing more on the graphical representation of the general equation. So the infinite number of solutions. Okay. So if we have infinite number of solutions algebraically, that means we also have infinite number of solutions graphically. Ooh, which is weird. So I'm gonna switch over to a picture to show you what this is gonna look like. Okay, so this is actually the slope field for the equation that we had. This is the slope field for the equation x squared. Let's see, I want to write on this. There you go. So this is for the equation that we had on the paper. Here, I'll go back to it. So sketch a slope field that represents the solution right here for dy dx equals x squared. And so, oops, I'm not even using my correct notation. So this is dy dx equals x squared. And this is the slope field for it. So this is all the infinite solutions for that differential equation. And if we think about this algebraically, it makes sense. So if I were to take the antiderivative of this to solve, I would get y equals 1/3 x cubed plus c, right? So this is my infinite solutions, which is just a cubic. x cubed, it's a cubic function that's shifted by c. So if you look at the slope field, you can kind of see it in there. Let's look right here. If we follow this slope field, this is exactly how you'd look at it. There's the cubic right there. And then I could move up. Let's move up to this point. And we have like the same thing. It's the cubic function right there. So it's just a cubic that's shifted in different directions. Okay, so the slope field is a graphical representation of all those infinite solutions. So you are going to be graphing stuff like this. You are not going to be graphing it in such fine detail. Whenever you will be graphing the slope fields, you will just be graphing a few points. Whenever, for your homework, usually it will specify which points you're supposed to find. If it doesn't, please don't do any more than like a 2x2. That's just about as much as you need to do. And so a slope field is just like what it sounds like. We are given dy dx. Oops. And dy dx obviously represents the slope at a given value, right? So at a given point, the slope is represented by x squared. And so, like at this point 0, where x equals 0, or 0, 0, we would just plug that into our equation, which is x squared, which is 0 squared. So that equals 0. So at this point 0, 0, I would draw a little line that has a slope of 0. And we could say the same thing for all these points, like 0, 1. Anywhere where x equals 0, the slope is going to be 0 squared, which is 0. So all along here, since x equals 0, I would draw a little line with a slope of 0. And then let's move over. Let's do this point right here. So at 1, 2, I use my x value because that's my equation. So 1 squared just equals 1. So I would draw a tiny little line with a slope of 1. And so a slope of 1 looks like a 45-degree angle. And then all along this line right here, since this is where x equals 1, let's say like at 1, negative 1. Doesn't matter what my y value is, the x value is still 1, so I will draw a line like that. And so you would just do this for all the values. We could look at 2, 0, 2 squared equals 4. A line with a slope of 4 is a lot more steep. Remember, it's rise over run, so you would think going up 4 over 1. It'll look something like this. It's just a lot more steep. Okay. And if we were to do the math, we would get a slope of 1 there and another slope of 4 right here. So just make sure when you're drawing your little slopes, you are consistent with them. And even though this is just a smaller piece, you can hopefully see the similarities between what we sketched and what was right here. So if I zoom in, this is what I just sketched. This is kind of the area that I sketched. So you can see at x equals 0, all those have a slope of 0. At 1 and negative 1, they have a slope of 1. And at 2 and negative 2, there's a steeper slope of 4. So that's a slope field. That's the basis of a slope field. I gave some little notes here. So remember that each little line is representing the slope at a given point. And when you connect those slopes, that will give you the equation for the solution for the differential equation. And the following are special cases. So when you have dy dx equal to 0, like we did up here, then you're just going to draw a little, this is a horizontal line. If you were to get that dy dx is undefined, an undefined slope, you're just not going to put anything. So whenever there's an undefined slope, no slope means leave it blank. Okay, so at an undefined point, there's no slope, so leave it blank. Okay, so this was just a quick introduction to slope fields. In the next video, you will get into it into more detail.